Hello everyone. Welcome back to the Tech Think Tank, your go-to resource for mastering AWS interviews. I'm Amber, and today we're diving into episode 5 of our series, Mastering AWS Interviews, the ultimate guide to the top 250+ questions. In the previous episodes, we covered the essentials, the fundamentals, and the key concepts you need to know. If you missed those, make sure to check them out because today, we're taking it up a notch. Get ready to elevate your problem-solving skills as we delve into advanced scenario-based questions that mirror real-world AWS challenges.
We're not just scratching the surface anymore. Today's episode is all about pushing your AWS knowledge to the limit. We'll be tackling intricate scenarios that you might encounter in high-stakes, real-world situations. This is where the rubber meets the road, and your problem-solving skills will truly shine. So, whether you're preparing for that dream AWS job or looking to enhance your skills, you're in the right place. These scenario-based questions are designed to challenge you, to make you think on your feet, and to ensure you're well-equipped to handle the complexity of AWS environments. We'll be covering a wide range of topics, from optimizing performance and security to handling large-scale migrations. The scenarios we discuss today are not just theoretical. They're drawn from the experiences of AWS professionals who've faced these challenges head-on. So, grab your notepads, fire up your AWS consoles, and let's dive into episode 5 of Mastering AWS Interviews. It's time to elevate your AWS game with advanced scenario-based questions. Are you ready? Let's get started. Let us start with our first question. Recently, an Amazon CloudFront distribution has been configured with an Amazon S3 bucket as the origin. However, users are getting an HTTP 307 temporary redirect response from Amazon S3. What could be the reason for this behavior, and how will you resolve the issue? Select any two from the options. The correct answer is options A and B. Let's see why. After setting up an Amazon S3 bucket, it may take up to 24 hours for the bucket name to be fully propagated across all AWS regions. During this period, you might encounter the 307 temporary redirect response when making requests to regional endpoints that are not in the same region as your bucket. To prevent receiving the 307 temporary redirect response, it's advisable to direct requests exclusively to the regional endpoint within the same region as your S3 bucket. In case you are using an Amazon CloudFront distribution with an Amazon S3 origin, CloudFront will route requests to the default S3 endpoint, which is situated in the S East 1 region. If you need to access Amazon S3 within the initial 24 hours of creating the bucket, you have the option to modify the origin domain name of the distribution. The modified domain name should include the regional endpoint of the bucket. For instance, if the bucket is in US West 2, you can update the origin domain name from AWS example bucketname.s3.amazonaws.com to AWS example bucket.s3.west-2.amazonaws.com. This adjustment helps ensure seamless access to your Amazon S3 resources during the initial propagation period. All the other options are not correct. In option C, S3 cross-region replication copies objects between Amazon S3 buckets in different AWS regions, ensuring compliance, minimizing latency, and enhancing operational efficiency. However, CRR does not resolve the HTTP 307 error. Option D. Use cache control and expires headers to manage CloudFront cache duration. This is unrelated to the HTTP 307 error. Option E. Amazon S3 transfer acceleration speeds up secure file transfers globally to S3 buckets. This is also unrelated to the HTTP 307 error. The development team at a company needs to implement a client-side encryption mechanism for objects that will be stored in a new Amazon S3 bucket. The team created a CMK stored in AWS Key Management Service, AWS KMS, for this purpose. The team created the following IAM policy and attached it to an IAM role. The team was able to successfully get existing objects from the S3 bucket while testing. However, any attempts to upload a new object resulted in an error. The error message stated that the action was forbidden. Which IAM policy action should be added to the IAM policy to resolve the error? The correct answer is option B. Let's see why. Generate Data Key provides a unique symmetric data key for external use outside of AWS KMS. This operation yields both a plaintext copy and an encrypted copy under a specified symmetric encryption KMS key. The plaintext key consists of random bytes, unrelated to the caller or KMS key. You can utilize the plaintext key for encrypting data outside of AWS KMS and store the encrypted data key along with the encrypted data. All the other options are not correct as none of them are suitable for client-side encryption. KMS, get public key, retrieves the public key of an asymmetric KMS key. Unlike the private key, which remains encrypted within AWS KMS, users with KMS, get public key permission, can access the public key. Not suitable for client-side encryption. KMS, get key policy, fetches the key policy associated with the specified KMS key. Not intended for use in client-side encryption mechanisms. KMS, get data key, this is a fabricated option included as a distractor. A company is migrating its two-tier legacy application, using MongoDB as a key-value database, from its on-premises data center to AWS. The company has mandated that the EC2 instances must be hosted in a private subnet with no internet access. In addition, all connectivity between the EC2 instance-hosted application and the database must be encrypted. The database must be able to scale to meet traffic spikes from any bursty or unpredictable workloads. Which option do you recommend? The correct answer is option D. Let's see why. Set up new Amazon DynamoDB tables using on-demand capacity for a pay-per-request pricing model. Implement a gateway VPC endpoint for a private and encrypted connection to DynamoDB. On-demand capacity adjusts instantly to workload changes without specifying read and write throughput. For provisioned capacity, specify expected reads and writes per second, enabling cost optimization with reserved capacity and autoscaling. Autoscaling adjusts capacity based on utilization rates over sustained periods. Note that occasional spikes may not be promptly addressed by autoscaling, but burst capacity can mitigate this, although it has limitations. Provisioned capacity suits predictable traffic with gradual ramps, while on-demand is ideal for unknown workloads, unpredictable traffic, and exact pay-per-use scenarios, especially for bursty or new workloads with rapid traffic fluctuations. Now let us see why the other options are not correct. Option A, set up new Amazon DynamoDB tables for the application with on-demand capacity. Use an interface VPC endpoint for DynamoDB so that the application can have a private and encrypted connection to the DynamoDB tables. Only Gateway VPC endpoint is supported for DynamoDB, so this is incorrect. Option B, set up a new Amazon DocumentDB with MongoDB compatibility cluster for the application with on-demand capacity. Use a Gateway VPC endpoint for DocumentDB so that the application can have a private and encrypted connection to the DocumentDB tables. And option C, A, set up a new Amazon DocumentDB with MongoDB compatibility cluster for the application with provisioned capacity with autoscaling enabled. Use an interface VPC endpoint for DocumentDB so that the application can have a private and encrypted connection to the DocumentDB tables. Amazon DocumentDB clusters, compatible with MongoDB, are deployed in an Amazon VPC. They are accessible within the same VPC or across different VPCs in the same or other AWS regions through VPC peering. Notably, DocumentDB does not support interface or gateway VPC endpoints, which is not correct. A social learning platform allows students to connect with other students as well as experts and professionals from academic, research institutes, and industry. The engineering team at the company manages 5 Amazon EC2 instances that make read-heavy database requests to the Amazon RDS for PostgreSQL DB cluster. As an AWS Certified Solutions Architect professional, you have been asked to make the database cluster resilient from a disaster recovery perspective. Which of the following features will help you prepare for database disaster recovery? Select any two from the given options. The correct answer is options B and E. Let us see why. Read replicas not only reduce the load on the source DB instance, but also serve as a disaster recovery (DR) solution. In the event of a source DB instance failure, a read replica can be promoted to a standalone source server. Moreover, read replicas can be established in a different AWS region, providing resilience in case of regional availability issues. And Amazon RDS ensures high availability and failover support through multi-AZ deployments, utilizing Amazon's failover technology for MariaDB, MySQL, Oracle, and PostgreSQL DB instances. The automated backup feature allows point-in-time recovery, backing up databases and transaction logs for a user-defined retention period. In multi-AZ setups, backups occur on the standby to minimize I/O impact on the primary. Amazon RDS supports automated backups in both single and cross-region configurations. Now let us see why the other options are not correct. Option A and C are used as a distractor here. RAID configurations are applicable exclusively to EC2 instance, hosted databases using EBS storage volumes. Different RAID levels, such as RAID 0 for increased I/O performance through striping and RAID 1 for data redundancy through mirroring, can be configured. Database cloning is supported exclusively for Amazon Aurora and is not available for Amazon RDS. Option D, for enhanced and consistent I/O performance in Amazon RDS, the provisioned IOPS storage option, utilizing SSD-backed storage, is available. It significantly boosts RDS database performance, but should not be considered a disaster recovery option. So these options are not correct. A company has its flagship application fronted by an application load balancer that is targeting several EC2 Linux instances running in an autoscaling group in a private subnet. AWS Systems Manager Agent is installed on all the EC2 instances. The company recently released a new version of the application, however, some of the EC2 instances are now being marked as unhealthy and are being terminated, thereby causing the application to run at reduced capacity. You have been tasked to ascertain the root cause by analyzing Amazon CloudWatch logs that are collected from the application, but you find that the logs are inconclusive. Which of the options would you propose to get access to an EC2 instance to troubleshoot the issue? The correct answer is option C. Let us see why. To preserve an instance from termination in an autoscaling group, consider suspending the terminate process. This action prevents instances from being removed, even if marked as unhealthy, due to reasons like exceeding the maximum lifetime duration or failing a health check. Alternatively, you can also suspend the replace unhealthy process to avoid the termination of unhealthy instances. Utilizing the Session Manager, you can log into the instance marked as unhealthy and analyze system logs to identify the root cause. Now let us see why the other options are not correct. Avoid suspending the health check process in Amazon EC2 Autoscaling for identifying unhealthy instances. This process regularly checks instance health and overrides manually set health statuses. Suspending it would prevent any instances from being marked as unhealthy, hindering root cause identification for specific instances. Suspending the launch process in Amazon EC2 Autoscaling won't help identify the root cause of instances being marked as unhealthy. This process adds instances during scaling events, and suspending it doesn't prevent termination of unhealthy instances. Enabling the EC2 instance termination protection, disable API termination attribute, does not prevent Amazon EC2 auto-scaling from terminating an instance. A data analytics company uses Amazon S3 as the data lake to store the input data that is ingested from the IoT field devices on an hourly basis. The ingested data has attributes such as the device type, ID of the device, the status of the device, the timestamp of the event, the source IP address, etc. The data runs into millions of records per day, and the company wants to run complex analytical queries on this data daily for product improvements for each device type. Which is the most optimal way to save this data to get the best performance from the millions of data points processed daily? The correct answer is option B. Let us see why. Apache Parquet and ORC are columnar storage formats ideal for AWS analytical applications. Partitioning data by date offers significant performance and cost advantages for daily analysis. Sorting data by device type enhances query execution speed for product improvement analysis. Now let us see why the other options are not correct. Storing data in Apache Parquet, partitioned by device type and sorted by date, is recommended for fast retrieval in AWS analytical applications. Using compressed CSV with partitioning by date and sorting by the status of the device, or by device type, is not optimal for complex analytical queries as they are row-based formats, not columnar storage. A company uses elastic load balancing to distribute traffic across multiple Amazon EC2 instances. Autoscaling groups start and stop Amazon EC2 machines based on the number of incoming requests. The company has recently started operations in a new AWS region and is setting up an application load balancer for its fleet of EC2 instances spread across 2 availability zones, with 1 instance as a target in availability zone X and 4 instances as targets in availability zone Y. The company is doing benchmarking for server performance in the new region for the case when cross-zone load balancing is enabled compared to the case when cross-zone load balancing is disabled. As a solutions architect professional, which of the given traffic distribution outcomes would you identify as correct? The correct answer is option B. Let us see why. In load balancing, when cross-zone load balancing is enabled, each node distributes traffic across all registered targets in all enabled availability zones, resulting in equal distribution. For instance, with 10 targets split across 2 AZs, each target receives 10% traffic. However, when cross-zone load balancing is disabled, each node only distributes traffic within its own availability zone, leading to uneven distribution among targets in different zones. In scenarios where cross-zone load balancing is disabled, each load balancer node can route its 50% of client traffic only to targets within its availability zone. This results in each of the 2 targets in availability zone X receiving 25% of the traffic, and each of the 8 targets in availability zone Y receiving 6.25% of the traffic. Now let us see why the other options are not correct. All the other 3 options provided indeed contradict the explanation given earlier regarding the effects of cross-zone load balancing. It's important to ensure that the information provided is consistent and accurate. If there are discrepancies, it's crucial to rely on the correct description to understand the behavior of load balancing configurations. A financial services company has multiple AWS accounts hosting its portfolio of IT applications that serve the company's retail and enterprise customers. A CloudWatch Logs agent is installed on each of the EC2 instances running these IT applications. The company wants to aggregate all security events in a centralized AWS account dedicated to log storage. The centralized operations team at the company needs to perform near real-time gathering and collating events across multiple AWS accounts. As a solutions architect professional, which of the given solutions would you suggest to meet these requirements? The correct answer is option D. Let us see why. Amazon Kinesis Data Firehose enables cross-account data sharing by aggregating CloudWatch logs from different AWS accounts. This involves setting up a CloudWatch logs destination and creating a subscription filter. Log event data can be processed centrally through a Kinesis Firehose delivery stream. For collaboration with other AWS accounts, cross-account data sharing allows receiving log events on AWS resources like Kinesis or Kinesis Data Firehose streams. This is facilitated by using a subscription filter with Kinesis Streams, Lambda, or Kinesis Data Firehose. Log events sent via a subscription filter are base64 encoded and compressed in gzip format. Now let us see why the other options are not correct. Given the hourly export frequency, Lambda is not ideal for near real-time solutions. For high-volume, high-velocity streaming, the Kinesis family of services is better suited. The deprecated CloudWatch Logs agent, limited to Linux, is advised to be replaced with the unified CloudWatch agent, supporting both logs and metrics across various operating systems, including Windows Server. The unified agent offers better performance but cannot publish data to a Kinesis Data Firehose stream. Using a subscription filter, you can work with Kinesis Streams, Lambda, or Kinesis Data Firehose. However, direct forwarding of events to CloudWatch logs in another account is not possible. Additionally, Kinesis Data Firehose streams cannot subscribe to EventBridge events. The security team at a company has put forth a requirement to track the external IP address when a customer or a third party uploads files to the Amazon Simple Storage Service, Amazon S3, bucket owned by the company. How will you track the external IP address used for each upload? Select 2 from the given options. The correct answer is options B and D. Let us see why. To discover IP addresses for object-level requests, uploads and downloads, in Amazon S3, enable either Amazon S3 Server Access Logging or AWS CloudTrail Data Events. With Server Access Logging, all bucket-level and object-level events are captured in a format akin to Apache Web Server logs. For AWS CloudTrail Data Events, the last 90 days of bucket-level events can be captured, and object-level logging can be enabled in JSON format. After enabling the respective logging method, review the logs to identify the IP addresses associated with each upload, noting that AWS CloudTrail may take a few hours to start creating logs. Now let us see why the other options are not correct. DPC flow logs capture information about IP traffic within a VPC, applicable to network interfaces, and can be published to Amazon CloudWatch logs or Amazon S3. However, it does not apply to S3 traffic. AWS Systems Manager Agent, SSM Agent, logs executions, commands, and health statuses on managed nodes, typically on EC2 instances, edge devices, and on-premises servers, but it does not pertain to S3. Amazon CloudWatch logs are used to monitor and store logs from various sources, allowing you to query, sort, and visualize them in dashboards. While it's versatile for EC2 instances, AWS CloudTrail, Route 53, and more, CloudWatch logs cannot track the external IP address used for uploads to S3. An edtech company needs to deliver its video on demand (VOD) content to approximately 1 million users in a cost-effective way. The learning material is in the form of videos with a maximum size of 10 GB each. The videos are highly watched when initially uploaded and subsequently have very less views after 6 to 8 months. While the old videos might not be accessed regularly, they need to be immediately accessible when needed. With trainers and material doubling every few months, the number of videos has exploded over the last few months, dramatically increasing the cost of storage for the company. Which is the most cost-effective way of storing these videos to address the given use case? The correct answer is option A. Let us see why. Amazon S3 Intelligent Tiering is a unique storage class offering automatic cost savings by optimizing data access tiers without performance impact or operational overhead. Designed for data with changing or unpredictable access patterns, regardless of size or retention, it automatically moves objects to the most cost-effective tier. A small monthly charge covers object monitoring and automation. It's particularly suitable for data lakes, analytics, new applications, and user-generated content. When storing objects in an Amazon S3 bucket, you can either have users access them directly or use CloudFront for distribution. CloudFront becomes more cost-effective for frequent access due to lower data transfer costs, and its cached content serves faster downloads from edge locations closer to end users compared to Amazon S3 alone. Now let us see why the other options are not correct. Amazon Elastic File System, Amazon EFS, cannot serve as an origin for a CloudFront distribution. While AWS Media Services are typically used for delivering live content globally, for a scenario focused on video on demand, VOD, using the suite of AWS Media Services may result in unnecessary costs. Additionally, EFS is around 3 times more expensive than S3, and using EC2 as the CloudFront origin incurs additional infrastructure costs. Therefore, these options are deemed incorrect. And that wraps up episode 5 of Mastering AWS Interviews, the ultimate guide to the top 250+ questions. I hope you found these advanced scenario-based questions both challenging and enlightening. Today, we delved into intricate scenarios that simulate real-world AWS challenges. Remember, mastering AWS isn't just about memorizing facts, it's about honing your problem-solving skills in dynamic situations. If you enjoyed this episode and want more, don't forget to hit that like button, subscribe to our channel, and ring the notification bell so you never miss an update. We've got more in store for you, from deep dives into specific AWS services to insider tips from seasoned professionals. Stay tuned for future episodes that will further sharpen your AWS expertise. Thank you for joining us on this AWS interview journey. Remember, practice makes perfect, so keep tackling those challenging scenarios. Your dream AWS job is within reach. Until next time, happy learning, and may your AWS interviews be a breeze.